Hello students, I hope you all are fine. So students, you know very well we have started unit hydrocarbon. We have done introduction of that unit. So today we will start alkane. Okay, so we will discuss about the method of preparation of alkanes today. Firstly, we can prepare alkanes from unsaturated hydrocarbons. You all know very well about the unsaturated hydrocarbons. Unsaturated hydrocarbons means which have double or triple bonds, means multiple bonds between carbon to carbon. Either alkene or alkyne. These are known as the unsaturated hydrocarbons. Alkene means carbon to carbon double bond, and alkyne means carbon to carbon triple bond. Here we are having alkenes and alkynes, and we want to form alkanes. We want to form alkanes from them. So how can we prepare, students? We will see by hydrogenation. By hydrogenation. By hydrogenation of alkene or alkyne. Hydrogenation means addition of hydrogen. Hydrogenation means addition of hydrogen. Like if we have any alkene, there are two carbons, they are having double bonds. Then complete valency by hydrogen, this one. There are two carbons, so it. Double bond between them, ethene. Any unsaturated hydrocarbon, alkene, means ethene you are having here. Then students, if you will do hydrogenation, hydrogenation means addition of hydrogen. Addition of hydrogen. Okay. For this we can use catalyst also, nickel, platinum or palladium we can also take. Okay, these are the catalysts. With the help of these reactions we can do at the first step. Okay, then student, what will happen? Very easily we want to add this hydrogen here. So for that, what will we do? Simply you can learn the reaction. Simply, first of all, you want to add hydrogen, one hydrogen to this one. One hydrogen you want to attach one hydrogen here. If you will attach, then what will happen? There are 1, 2, 3, 4, 5 bonds. 5 bonds. But carbon is tetracovalent only. Carbon is tetracovalent only. Okay. Means you need to break this one. If you will break this one, then there are only 3 bonds. So one hydrogen you can give to this one. Simply you are doing addition of hydrogen. Simply you are doing addition of hydrogen. Then first, these are two carbons, two bonds, it is forming with hydrogen, and this one also. There are two bonds between these two carbons. One you can break and you can form that bond with hydrogen, and one with this one. So simply you can do, if any alkenes you are having, then simply what will you do? You will break bond between carbon and you will give one hydrogen to this one and one hydrogen to this one. Okay, so by hydrogenation we can convert unsaturated hydrocarbon into alkanes or saturated hydrocarbons. Okay, we can say hydrogenation because addition of hydrogen taking place here, or we can say reduction also. We can say reduction also. Reduction means addition of hydrogen. Addition of hydrogen is also known as reduction. Okay, and you know very well these are the catalysts which are used for the reduction. Okay, in other reactions also we will do reduction, then we can use this catalyst. Okay, then here these platinum, palladium, this help to proceed the reactions very easily. Then if you have alkyne, let us consider you are having ethyne. If you are having only one unit of hydrogen and you want to do reaction in presence of nickel and platinum, so again hydrogenation you will do. Here you are having only one unit. So firstly same thing you will do, this carbon forming one bond with hydrogen and three bonds with other carbon. So one bond you will break, you can give one hydrogen to this one and one hydrogen to this one. First of all, alkyne, two carbons, so it is ethyne. First of all, ethyne will convert into ethene. But if you are having two unit, okay, then further one more unit of hydrogen you can use for breakage of this bond also, and you can get ethane. Clear or not? So simply what are you doing? Simply addition of hydrogen you will do. By addition of hydrogen, unsaturated hydrocarbon can be converted into the saturated hydrocarbons. Alkyne can be converted into alkene. Alkyne can be converted into alkene, and alkene further into alkanes. So it will depend on the number of units. If directly you are having one unit and you want to do reaction, then you will write only this one product, alkene. Clear? But if you are having two units of hydrogen and in this way given, complete the reaction, then students directly you will form, because two unit you are having, then they can break two bonds and directly you can get ethane. Any doubt in this one? Yes. So one method is the hydrogenation. Then our next method of preparation by Grignard reagent. First of all, you should know what do you mean by the Grignard reagent. You know, students, Victor Grignard was a scientist who gave the Grignard reagent. Who gave the Grignard reagent? He got Nobel Prize also for this in 1912. Okay, so Victor Grignard gives us the Grignard reagent. That was this one. When alkyl halide, alkyl NER group, one hydrogen replaced by any halogen, when any halogen, like if I have methane, this one is alkane. If one hydrogen replaced by fluorine, chlorine, bromine, iodine, like if I'm replacing one hydrogen by bromine, then this is the methyl bromide. Methyl bromide. Okay, so when any alkyl halide react with magnesium metal, okay, in presence of dry ether, we will do this reaction in dry medium, not in wet medium, because it is highly reactive. Okay, so we will do this reaction in dry medium only in presence of dry ether. Then what will happen? You know very well, magnesium has tendency to lose 2 electron because magnesium atomic number 12. Its configuration 282. For getting stability, it can lose 2 electrons. It can lose 2 electrons. Okay, and you all know very well, magnesium is more electropositive because it is metal, and here carbon is non-metal, and halogens are also non-metals. So they are more electronegative as compared to metal. As compared to metal, then it has tendency to lose 2 electrons, and they have this carbon and bromine has tendency to gain electrons. Okay, then what will happen finally? This magnesium will give 1 electron to this one and 1 this halogen. Clear? So RMGX, this one is the Grignard reagent. This one is the Grignard reagent. Grignard told us that when alkyl halide and magnesium react with each other in dry ether, in presence of dry ether, then they give us alkyl magnesium halide. Alkyl magnesium halide. And this reagent is known as the Grignard reagent. Okay. You can write any, if alkyl group we are having CH3, Mg, and halide we are having bromine, then methyl magnesium bromide. This one is also Grignard reagent. Alkyl group you can take C2H5, any other magnesium, halogen you can take chlorine also, then ethyl magnesium chloride. Okay, so what is the Grignard reagent? Grignard reagent is alkyl magnesium halide. Because it was given by Grignard, that's why it is known as the Grignard reagent. Okay, but we want to prepare alkane from this one. How we can form? How we can form? Firstly, we have prepared alkyl halide. Alkyl halide, if we are having, then it will react with magnesium metal in presence of dry ether. In your book may be written diethyl ether. This is also same thing, diethyl ether, ROR group. Okay, so this is common name, diethyl ether, diethyl ether, or IUPAC name ethoxyethane, ethoxyethane, or simply you can write dry ether, dry ether. Okay, so in this, in presence of dry ether, firstly you will get RMGX. RMGX, this is the Grignard reagent. Now you will prepare alkane from this Grignard reagent. How will you prepare? You will react Grignard reagent with water. With water. Okay. Very simple to write the product RMGX. You know very well R group means it is forming bond with carbon. With carbon, and carbon is less reactive. Carbon is less electropositive as compared to the metal. So with this you can write this one. See. I am writing this one CH3 MgBr Grignard reagent. So you can see here magnesium is metal, so this one is more electropositive as compared to carbon. Then negative charge will attain by this carbon and positive by this magnesium. Clear? You will break this one also. Water H positive, OH negative. You will do reaction in simple way by electrostatic force of attraction only. Means you will interact positive with negative and negative with positive. Simply you will do. Okay. Then this positive will be attracted by negative, will be attracted by negative. Then CH3 negative and H positive. CH4, CH4 plus MgBr positive you are having here and OH negative. So MgBr OH. Clear or not? So if you are having Grignard reagent, then by hydrolysis only you will react this with water only. Just you will break in positive and negative part. Magnesium more electropositive, so Mg it attain positive charge. Carbon is non-metal, so with respect to this one, this is more electronegative, so negative here. Okay. Then what will happen? Negative and positive you will break, water also you will. Then positive will be interacted by the negative. CH3 negative and H positive. CH4, what is this? This is methane and methane is alkane. Clear or not? And this one MgBr and positive interacted with negative. Then MgBrOH. Clear or not? So now you know why we are doing reaction in presence of dry ether. Because if this one is wet, then directly we will get alkane, not Grignard reagent there. Clear or not? Yes. So for preparation of Grignard reagent, we will take dry medium. Clear? If any, you are having C2H5, MgBr, so simply you will do reaction with water. So simply you will negative, positive, H positive, OH negative. Positive goes with negative, C2H5, negative plus 1 H. So C2H6 plus MgBr and OH. You need not to learn, just try to understand the method, beta. Simply you can write the product. Okay. In what way you will get reactions in your exam? You will get in this way. Complete the following reactions. Complete the following reactions. Let us consider it is given. Simply you will get in this way. Complete these reactions. Okay, then you know very well what will we do. Hydrogen and nickel means hydrogenation. You will do hydrogenation. In hydrogenation, you know very well, you will break double bond. You will break double bond. CH3 double bond is here. So you will break this one and you will give one hydrogen to this one. So already one hydrogen, one more you will give, so CH2, and you will give one hydrogen to this one. So already two are there, then one more, three. Propane you will get. Here you know very well, dry ether you are having, means alkyl halide, then magnesium. So RMGX will, R is CH3H7, then MgX is Cl here. First you will get Grignard reagent. Okay. Yes. Then water you are having. Then you will break this one. In positive and negative. And water also you will break. Then you will attach positive with negative and negative with positive. Then you can write the product. Clear or not? Yes. Then one more method of preparation. This one is the naming reaction. Wurtz reaction. Wurtz reaction. Wurtz reaction, students, further, if you are having alkyl halide, and you want to do reaction with sodium metal, okay. One more unit we are having alkyl halide. This reaction you will also do in presence of dry ether. Dry ether. Okay. Then simply, what will you do? Remove this one only. Then R and R. Means higher alkane you will get. Plus two NaX. Why? Let us consider you are having CH3Cl plus sodium metal. One more unit you are having in presence of dry ether. Here, students, this chlorine is more electronegative as compared to carbon. Okay. Then it can attract electron towards itself. Means Cl negative can be removed. Okay. And one sodium can lose one electron only. Then for two chlorine we need two sodium. We need two sodium here. Clear? That's why we will take two sodium. And finally, two NaCl you can remove. Simply you can write reaction. Here we need not to see about the mechanism because simple. We can very simple to write this one. Okay. Here, students, you are having methyl chloride only. But you are getting ethane. Means during conversion. In 12th class, you will discuss about the conversion also. Means if you are having only alkane, okay, and from alkane you want to convert into amine, into carboxylic acids, means in 4 and 5 steps, how can you do reactions? So you will keep in mind, if you want to get extended carbon, means you are having only one carbon here, okay, and you are getting product of the two carbons, mean higher alkane you are getting here, higher alkane you are getting here. Clear or not? Then in this way, this is the Wurtz reaction, this is the Wurtz reaction. Clear? If you are having this alkyl halide, not you are having, if you are having chloro or halo, means halobenzene, means aryl halide. If you are having, aryl, benzene is also known as the aryl, okay. If you are having aryl halide and sodium metal and one alkyl halide, reaction further you are doing in presence of dry ether. Same way you will do reaction. You can remove this one. 2 NaCl plus benzene and this one. In same way we are doing reaction. But student, this is known as the Wurtz fatigue reaction. Same reaction you will study in 12th class, same reaction. Okay, but there you will study this reaction in chemical properties of alkyl halide. And here you are doing this reaction in method of preparation of alkane. Clear or not? This is known as Wurtz fatigue reaction. And if you are having both aryl halide, present same dry ether. In same way you will proceed reaction 2 NaCl plus this one in same way we are doing reaction, but name of this reaction is fatigue reaction. Fatigue reaction. Clear? If both alkyl halide you are having, alkyl halide and alkyl halide, okay, same reaction you are doing, just remove this one and attach this one and this one. This is Wurtz reaction, one aryl halide and one alkyl halide. Then Wurtz fatigue reaction. If both are aryl halide, then fatigue reaction, only fatigue reaction. This is Wurtz fatigue, one aryl, one alkyl. Both are aryl, then it is fatigue reaction. Clear or not? Name are different, but reaction is same. Clear? What is name for this one? Biphenyl. This is the biphenyl. Clear or not? So today we have done 3 methods of preparation. First from unsaturated hydrocarbon, second from Grignard reagent, and third one is the naming reaction. That is the Wurtz reaction. Okay, some more methods are there. We will discuss about them tomorrow. Okay, students. So thank you. Have a nice day.